Next topic I'm going to talk about force on a current carrying conductor in a magnetic field. So if I keep a current carrying conductor, so here is a current carrying conductor, current is going in this direction, I. It is placed in a magnetic field. What is going to happen to that conductor? That's what we're going to learn in this video. So before finding the force, we need to know the right hand rule. So here is the right hand rule. When I looked into the internet, there are so many rules or so many ways. I'm going to use this picture because I have been following this method for a long time. Okay, so here the thumb indicates the force direction, and the thumb indicates the force direction. Forefinger indicates the current direction. So this is forefinger. So let me say thumb, forefinger, and middle finger. Okay, place them 90 degrees to each other. Okay, you have to place each other 90 degrees to each other. Now the thumb indicates the force direction, and forefinger indicates the current direction, and middle finger indicates the magnetic field direction. Okay, so now what happens if I place a current carrying conductor in a magnetic field? If I place a current carrying conductor in a magnetic field, it will experience a force. The amount of that force, F equal to BIL sine theta. The amount of the force on that conductor is equal to BIL sine theta, where B is the magnetic field. Okay, I is current in that conductor, how much current is passing through that conductor. L is length of the conductor which is exposed to the magnetic field, length of the conductor. Okay, and theta is angle between B and I, angle between B and I. Now as I mentioned, every current carrying conductor will experience a force. That force is equal to BIL sine theta. Now if you look at this theta, theta is angle between B and I. So if I place theta equal to 90 degrees, so the angle between B and I, if you look at here, B is going in this direction, I is going into the board or into the paper in this case, then there are 90 degrees. Then we will see the maximum force. What if I have B and I in the same direction? Theta is 0 in this case, sine 0 is 0, so F equal to 0. So if you place a current carrying conductor perpendicular to the magnetic field, it will experience maximum force. Now we will find out the direction of that force by using this right hand rule. Okay, so in the right hand rule, thumb indicates the force, middle finger indicates the magnetic field direction, and forefinger indicates the current direction. Now if you place them perpendicular to each other, okay, here is the vector diagram you can see. So the middle finger indicates the magnetic field direction. Make sure that you indicate your middle finger towards the magnetic field direction, and the current is going into the board in this case, or current is going into the board in this case, or in the paper. Now the conductor is going to experience a force towards down. That's what the right hand rule indicates. So from this video we learned that if we place a current carrying conductor in a magnetic field, it will experience a force, and we learned that what is the direction of that force. Now we'll solve a couple of examples. Now here is the first example. Now here is a current carrying conductor. I'm assuming current is going into the board, so this indicates the current. Now the magnetic field is going in this direction. This is the magnetic field, not I. Okay, by using right hand rule, can you guys tell me which direction that which direction that conductor is going to move? Okay, so if you calculate, actually it's the same example what we did, it's going to go towards down. Now here is another example. A magnetic field, that's B, is coming out of the board and the current is going in this direction. Okay, which direction the force is so which direction the force is going to be on this conductor in the second example. So if you look at the second example, I'm going to explain it one more time. Magnetic field is coming out of the board. Dot indicates, as I mentioned, vector, it is coming out of the board, out of the page or board. This is into the page. Okay, you need to remember this. We're going to practice, or we're going to do lots of examples by using these vectors. Okay, here also the force is going to be towards down, F equal to in the downward direction. Here is third example, example 3. I don't know why I'm choosing all towards down. Let me choose this direction. Here is my current coming out of the board. Okay, and magnetic field is going in this direction. Okay, B is going to be in that direction. Now tell me which direction the force is going to be on this conductor. Okay, so if you look at here, I mean, place your middle finger towards the towards up, and your current is coming out of the board. If you look at it, your force is going to be towards left. Okay, thank you.